Leetcode 435, non-overlapping intervals. It's a medium problem, and I would say quite standard for medium, so nothing special easy or very hard, just your standard medium. What might be, however, interesting about it is that it likes to reappear during interviews, especially for big tech. So you might like to take a deeper look into it and try to study it on your own. But here is the description. Given an array of intervals called intervals, which is basically like a class of problems on Leetcode. Yeah, there is a lot of problems related to intervals, and what they mean by those intervals is that you have what we have in Python list of lists, but those inner lists have just two elements. Yeah, so it could be just a list of pairs. Yeah, and there is also another constraint for this inner lists or those inner pairs is that though they consist of two integers and the first one is smaller than the second one. So you might think of them as an interval where the first is like representing some kind of start or some kind of starting point, and the second is representing some kind of endpoint. Yeah, and the next is the description of what we should do. We should return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Yeah, and of course, as usual or as very often, the most appropriate way to solve it is not just by doing exactly the thing they want us to do or what they are telling us to do, so not by removing, but by doing something else that will be a little bit more optimal, but will result in a similar effect. Yeah. So instead of removing, we will try to do something else, and you might already think about what could this potentially be, how to do it in an optimal way. Yeah, and there is a note at the bottom that intervals which only touch at a point are non-overlapping. For example, 1 and 2 and 2 and 3 are non-overlapping. Yeah, and of course we want to make them non-overlapping. So that kind of thing is okay, and we will have, I think, exactly the same intervals in the first example. So let's take a look. The following intervals: 1 and 2, 2 and 3, 3 and 4, and 1 and 3. Yeah, 4 intervals, and 1 can be removed. Which one? 1 and 3 can be removed, and the rest of the intervals are non-overlapping. Yeah, because this one, it goes between the first and the second. Yeah, and if we remove it, then both of them are non-overlapping, as it was stated here above. And we can't remove anything else since the next one, 3 and 4, is already non-overlapping, so it's already good. Yeah, we don't want them to overlap. And the second example, we have 1 and 2, 1 and 2, 1 and 2. Yeah, and of course, intervals can be repeated. There was nothing stated here that they need to be unique, and we also have to get rid of them in such case. Yeah, so in this case, we have 3 exactly same intervals, meaning that we can remove 2 of them, and the last one or the first one, whatever, there will be one left, which will be non-overlapping, since it will be the only interval left. And the third example, it could also be the case that all the intervals are already non-overlapping, so we remove nothing. But let's take a look into this example and think about some possible ways in which we can solve it. So, non-overlapping. So if we draw it like this, and let's make an axis like this, 1, then 2, 3, then 4, and actually we have more space, so I can put them further apart to make it more visible. Yeah, and let's draw the first interval, and this one, it will be 1 to 2. Yeah, and we can draw it like this, from 1 till 2, Then let's make the second interval blue. 2 till 3. And let's make this one orange. 3 to or till 4. Yeah, and there is the last interval which we can make red since it will be removed, and it goes from 1 like this till 3. And this is the one that is bad since it's overlapping two other intervals, yeah? And we don't want them to overlap. Two other intervals. Let's make it like this. We can move everything here. Okay. Yeah, so what can we do? First of all, we can sort. As you can see, this interval, the last interval on which we drew as red was actually, when you draw it on an axis, it comes before the third interval. Yeah. So the third interval, which appeared first in the input list, actually represents an interval which is more to the right or more to the end if this goes to some end. But what I try to say is that they are not sorted, or they don't have to be sorted. Yeah? So first of all, to do anything, we should sort. Sort the intervals by endpoint or by the, don't write this name, maybe by the second element, like this. Yeah, and inside our interval, we have, of course, two elements, start and end. And then we can, once we have sorted, what can we do? We can iterate through each pair in the sorted list, and then do the following. If the end, or maybe like this, if previous end is less than or equal to current start, yeah, and maybe let's here add additional explanation and keep track of current and previous. Yeah, so we'll keep track of two intervals at the same time, and if the end of the previous interval is greater, is less than or equal to the current, that means that they are non-overlapping. This is good sign. Yeah. So this means they are non-overlapping, and this is what we want, meaning that we can increase some counter. we have found one non-overlapping, one additional non-overlapping pair of pairs. Yeah, so previous and current are non-overlapping. We can count the number of non-overlappings and otherwise do nothing. Else do nothing. And that's it. Final answer lies here. Yeah, if we count all non-overlappings and we know how many they are in the input, then like the number of kept plus the number of skipped is equal the initial length, yeah, or the number of all elements. Which means that our final result is length of input minus a counter. And that's it. We can try it here. Yeah, so if we sort like this, we can even keep two of them to not have any step skipped. So here is the example. So after sorting, we have something like this, and then we can create some counter, which first set to 0, and we can iterate. Yeah, each time we keep track of the last end, like the second element of the last pair and the first element of the current pair, like this. Blue, we can make it, let's make it a bit thicker. Blue and blue. Like this. Yeah, and we check this condition. Is the previous end less than or equal to current start? No, it's not. That means that we get rid of this and we move further. Yeah, is the current start less than or equal? Yeah, it's equal, yeah, meaning that we can increase the counter by 1 and remove this. Yes, and we can go further. And this time we didn't remove, meaning that we have to move the previous. And of course, 3 is equal to 2. And that's it. But we have our answer is right now, our counter is set to 2. But sorry, we have to also keep the first element. Yeah, so we will initialize the counter to 1, not to 0. Yeah, since we are always keeping the first element. So in fact, it should be like this. First it should be 1, then it should be 2, and then it should be, by the end, 3. Yeah, that's correct. And the length of the input is 4. 4 minus 3 is 1, and that was the answer. Yeah, so now we have to just convert it to Python, and we can check, for example, the intervals are empty. Then we return 0, Otherwise, we can sort the intervals. Using the second element, yeah? So, like this. Sort by second element. And then we have to initialize the current equals intervals on the first position, and the counter equals to 1. Yeah, and we can have current start and previous end. Since we will be updating the current, the first element we can already set to previous, and we will start from the second element in the loop. So for current start, current end in intervals starting from 1. Yes, and what did we say? We said that if previous end is less than or equal to current start. If previous end less than or equal to current start, then counter plus equal 1. Yes, and previous end equals to current end. And that's it. And by the end, we return the length of intervals minus the counter. And it keeps track of how many intervals we keep. Let's now check if there are no errors or any mistakes. And here, for the first 3 cases, it works. Now let's try to submit for all the cases, and we are faster than 88% of other competitors.